Okay, in this example, we have a function f of x is equal to negative 3x plus 7. We have three parts. We're going to practice finding derivatives and inverses and evaluating. So the first part says just take the derivative of f and evaluate it at 2. So when I take the derivative of f of x, I'm just going to get negative 3. And if I evaluate it at negative 2, because negative 3 is a constant, it doesn't matter what I evaluate it at, but specifically if I evaluate it at negative 2, I'm still just going to get negative 3. For part B, we want to find the inverse of this function, f of x, and evaluate it at y. So when I find the inverse, I'm going to switch my x's and my y's. So I have x is equal to negative 3y plus 7. I need to resolve this for y. So when I resolve this for y, I'm going to get x minus 7. And then I'm going to divide by 3. That's going to give me my y, which is my inverse. The question wants it evaluated at y. So I'm going to go ahead and make sure that I plug in y where I see x. So I have y minus 7 over negative 3. So that's the answer to part B. So I have y minus 7 divided by negative 3. For this last part, we need to take the derivative of the inverse and then evaluate it at f of negative 2. So here's my inverse function. I'm going to rewrite my inverse function as two separate fractions. I think it might make it easier to see what's going on here. This is just a linear function. I have negative 1/3 x plus 7/3, because that double negative makes it a positive. So when I take the derivative of my inverse function, I'm just going to get negative 1/3. When I evaluate it at f of negative 2, if I look back up here and I plug in negative 2 for f, I'm going to get out 13. So really, I need to evaluate this at 13. Because this is a constant, it doesn't matter what I'm evaluating it at. When I plug 13 into a constant function of negative 1/3, I'm just going to get negative 1/3.